Okay, let's look at problem 5 on the final review. It basically gives you the graph and asks you some questions. This particular one asks you to do both a sine equation and a cosine equation, amongst some other things that it asks you. The actual final one simply asks you for the amplitude, period, phase shift, which is these three things, and then asks you to write your own equation. And looks like you could use a sine or a cosine, whichever one you decide you like best, I guess. So here we go. I filled some of these in. Amplitude, you just look at your graph. How far up does it go? How far down? Absolute value is just 1. So it's going up 1, down 1. That's an amplitude of 1. Period. Really, you can take the measure of the period anywhere, but the easiest thing to do is say, okay, if I start here, I do a complete cycle and then I repeat the cycle here, right? So I'm repeating here. And so from here to here, it's just pi. And so your period is pi. So you just write that down. Okay, so sine wave phase shift. That is, sine wave normally starts here at 0, 0, but we've shifted that over this far. Now, you could argue that you maybe shifted it way over here, and that would work as well. You could work the problem that way. But generally speaking, you just take the smallest phase shift that generates this pattern and stick with that. So we're going to go with this right here, which if this is pi over 2, this is pi over 4. So if it's a sine wave that we're going to use to graph this, then we need to phase shift it by pi over 4. Now remember, a cosine starts up here, right? So now we've phase shifted it all the way over here to pi over 2. So our phase shift for the cosine is pi over 2. So right off the bat, we got 4 out of the 6. And now all that remains is simply writing the equation. Now, there's basically two things. We don't need to worry about the amplitude, because the amplitude's 1. But we do need to worry about the phase shift. Okay, so what would the phase shift look like? Well, remember, subtracting moves it to the right. So we're going to subtract the phase shift. So now we've got sine of the angle minus pi over 4. This takes care of the phase shift, but it doesn't take care of the fact that the period is half as long as normal. Normally it goes from 0 to 2 pi. Now we're only going from 0 to pi, which is exactly half. And the easy way to work that out is say, well, really I'm taking the sine. Then if I want to shrink the period, I want to multiply this by 2. This will actually get it for you. If you wrote this as the function and you had these parentheses here, you'd be correct. I've had students in the past write this without the parentheses, and that would be incorrect. The other way to write this is to go ahead and distribute your 2. And then this becomes pi over 2. Okay? So this is generally the way you'd probably want to if you write it this way. I'm not going to count off. As long as, and keep this in mind, as long as you have these parentheses in here, otherwise then this becomes incorrect. So what do you do now? What if you're at this point in the game and you're like, okay, I think this is right. It mentally makes sense to me, but how do I know for sure? Well, imagine somebody gave you this to graph and you wanted to find the period and the phase shift. What would you do? Well, you would stick it in. You would stick it in this equation. You'd say, well, normally 2 theta minus pi over 2 normally goes from 0 to 2 pi. But we've got this thing instead of just theta. We're going to add the pi over 2 to both sides. So we end up with pi over 2 theta this becomes, what does it become? 5 pi over 2? Let's call it 5 pi over 2. And then basically we're going to multiply by a half, right? Or divide by 2, multiply by a half. That leaves theta here. That makes this pi over 4. And that makes this thing over here 5 pi over 4. Okay, so here's our phase shift. And that's correct. We were predicting a phase shift of pi over 4. 5 pi over 4 minus pi over 4, right? The distance from here to here is our period, and that happens to be pi because 5 pi over 4 minus pi over 4 is actually pi. So this thing actually works out, which means that when we come over here, let's go ahead and write this in. We got sine, and I'm just going to write the 2 pi minus pi over 2, or 2 theta. Then when we come down here and do the cosine equation, we maybe don't have to check it, right? We know that the period is going to be dealt with the same way. We're going to have 2 times, this is going to be minus our phase shift of pi over 2. So we simply need to distribute and get 2 theta minus pi. And that is our cosine equation. So this is going to be cosine 2 theta minus pi. And of course we probably should have a y equals just to be correct. And that's all you have to do for that one. Keep in mind that the nice thing about this, they break the question out. A lot of the questions are just what I would call a quick hitter. You just, if you know what amplitude is, you can answer it very quickly. If you know what the phase shift is, you should be able to answer that fairly quickly. The problem on the final, I'm going to tell you the amplitude is not 1, but it's fairly easy to read. The phase shift is, I'll have to say, a little bit wonky. For that reason, I may substitute the equation for something. It's just because it's hard to read. It's not because it would make the problem difficult. Just because I don't like the way it's kind of hard to read. So I guarantee that it won't be any more difficult than this, other than maybe the amplitude will play in. And just remember that this number in the end would simply come out here and not affect anything else we did. It wouldn't affect anything else. It would just be a number that precedes either the sine or the cosine. So that's all there is to that.